1960, Kostomy, Soviet Union. A young physicist, Nikolai N. Fedyakin, is fiddling with some hair-thin quartz capillaries. Think kinetic sculpture meets alchemist's dream. He's convinced that even the most boring stuff has secrets. So he's watching ordinary water vapor condense inside these tubes. Suddenly, he spots what looks like a scientific scandal. Two different liquids. One is the clear water we all know and love, the other is weirdly turbid, thicker, and flows like syrup. Pancakes, anyone? He weighs the denser stuff on a precision balance. Turns out it's about 10% heavier than regular water. In a cloth-bound notebook, he scribbles the first entry in what's about to become a legendary tale. The Legend of Polywater, the polymeric water that newspapers would soon hype up as a miracle fluid. In the Soviet Union, scientific excitement always mingles with political caution. It's like trying to dance at a party while keeping an eye on the chaperone. The Academy of Sciences dislikes premature publicity that might invite Western criticism. They prefer to keep things hush-hush, like a secret recipe for borscht. Yet the rumor nevertheless leaks through terse notes in Doklady and Kolloidny journal. It's like trying to keep a juicy piece of gossip under wraps. Good luck with that. Fedyakin's anomalous water reaches Moscow and the ears of Boris V. Derjagin, already famous for his work on surface forces and DLVO theory. This guy's like the rock star of Soviet science. With imperious energy, he summons assistants, secures ultra-pure quartz capillaries, and refines the protocol. It's like he's assembling the Avengers, but for science. Not only does he reproduce Fedyakin's results, he pushes them further. Talk about overachieving. A viscosity 10 times that of distilled water, a freezing point of minus 40 degrees Celsius, a boiling point above 150 degrees Celsius. Values that, if true, would rewrite sections of thermodynamics. It's like finding out your grandma's cookie recipe defies the laws of baking. Derjagin senses the impact instantly. It's like he just discovered the scientific equivalent of sliced bread. A new state of matter, perhaps a polymer of H2O, potentially the key to super lubricants or nuclear reactor coolants. Imagine the possibilities. No more squeaky doors. In the tense Cold War climate, every Soviet advance echoes as a threat across the Atlantic. It's like a high-stakes game of scientific poker. June 1966, Nottingham. Amid campus flags and probably some questionable fashion choices, the Astrophysical Group throws a 50th anniversary bash, and Derjagin drops his findings like they're hot in a packed lecture hall. Enter John Desmond Bernal, the Irish crystallographer with a vision and probably a killer accent. Bernal stands up and in true dramatic fashion declares, "If these data hold, we've just hit the physical-chemical jackpot of the century." And just like that, Polywater goes from nerdy lab experiment to the hottest thing since sliced bread. Scientists everywhere are buzzing, probably wishing they had discovered it first. Even the Pentagon gets in on the action, with a top-secret dossier landing on their desks, titled Polywater Gap. Sounds like a sci-fi movie, right? Imagine this. What if the Soviets have a superfluid that's tougher than your grandma's old fruitcake? A fluid so stable it could be the ultimate high-pressure lubricant. Or even worse, what if it could mess up Earth's biosphere like a toddler with a crayon on your freshly painted walls? Just 3 years earlier, Kurt Vonnegut dreamed up Ice 9, a crystal that could freeze the planet's oceans faster than you can say global cooling. The Washington Post just had to change a number to get a catchy headline. Poly 9. Now that's some creative journalism. Phones are ringing off the hook on American campuses, even at 3 a.m. In Ann Arbor, Ellis Lippincott and Robert Stromberg are burning the midnight oil, scrambling NSF proposals to figure out these weird infrared bands. Meanwhile, Soviet papers are claiming they've found long chains of hydrogen-bonded H2O. Sounds like a sci-fi plot, right? Over at Princeton, the thermodynamicists are scratching their heads, trying to see if this denser water phase fits the Clapeyron curve. Spoiler, it's complicated. In Los Alamos, theorists are feeding colossal CDC computers with lattice models. It's like trying to solve a Rubik's Cube blindfolded. The simulations, full of numeric compromises, are just believable enough to unlock fresh Defense Department millions. Cha-ching! So, here's the kicker. Reproducibility is playing hard to get. Cambridge chemists, armed with their fancy quadruple distilled water and ion exchange columns, find absolutely nothing. Nada. Zilch. Others get these tiny droplets that disappear faster than free samples at a food festival with just a 2-degree temperature rise. And then there are those who see something in between, changing from capillary to capillary like a moody teenager. So, is polywater a real but super shy phenomenon, or just a lab trick that only shows up under perfect conditions? The closer we get to proving it, the more polywater looks like a mirage in the desert. Thirsty, anyone? Derjaguin feels his authority starting to wobble like a Jenga tower. In the Journal of Colloid and Interface Science, he publishes what sounds like a recipe for disaster: caustic wash, acid wash, triple distilled rinse, and warns that a single dust mote can doom the experiment. Talk about high stakes. But saying that is like admitting a tiny imperfection can topple the whole thing. And when that happens too often, the scientific community starts to think the foundation is made of jello. Critics zoom in on the density data. Others suggest the viscosity spikes are just micro bubbles playing tricks. From Caltech, Richard Feynman jokes, if there were a more stable form of water, Earth would have turned into goo millions of years ago. Imagine that. Derjaguin feels the heat, and it's not just from the Bunsen burners. In the Journal of Colloid and Interface Science, he drops a bombshell protocol: caustic wash, acid wash, triple distilled rinse, and warns that even a single dust mote can ruin the whole shebang. But saying that is like admitting a tiny flaw can bring down the whole house of cards. And when that house collapses too often, the scientific community starts to think it's built on quicksand. Critics zoom in on the density data. Others say the viscosity spikes are just micro bubbles playing tricks. From Caltech, Richard Feynman jokes, if there were a more stable form of water, Earth would have turned into a giant jelly donut millions of years ago. The debate spills out of the nerdy science journals and into the mainstream. Time, Newsweek, The Wall Street Journal, they're all over it. Headlines swing between miracle fluid and end of the oceans, talk about mixed messages. Even CBS's Walter Cronkite gets in on the action, coolly suggesting that polywater could change everything from jet engines to the entire planet's climate. No pressure, right? Every broadcast sounds like a Kurt Vonnegut novel. Think Ice 9, the ultimate ecological weapon that could freeze the world's water in no time. Yikes! The public? They're hooked. Half of them are ready to party. The other half are stocking up on bottled water. Meanwhile, in a not-so-fancy lab, a Franco-Canadian physicist named Denis Louis Rousseau, newly hired at Bell Labs, a handball enthusiast, and allergic to jumping on bandwagons, watches the polywater hype with a growing sense of, "Are you kidding me?" He spots a glaring omission. The polywater papers never really show what's in their samples. Why so secretive about the ingredients? In 1970, he takes a break from the corporate grind, plays a grueling handball match, wrings his sweat-soaked t-shirt into a beaker, filters the liquid, injects it into a super clean quartz capillary, and runs a high-resolution infrared spectrum. What pops up on the screen? A perfect match with the polywater spectrum from Lippincott's group. Same bands, same intensities, same shifts. Rousseau chuckles. If polywater is just my gym sweat, we've got a serious problem. He sends a paper to Science with the hilariously straightforward title, Polywater, Polymer, or Artifact. Published on March 27, 1970, it blows up the field. So a week later, the folks at Leeds try it with human spit. Yep, you heard that right. And within a month, some Tokyo chemists say, hold my beaker, and find out a not-so-clean capillary plus a sprinkle of colloidal silica makes a slightly thicker, slightly goopier liquid. No fancy polymer here, just some dirty water. Reactions swing between oops and what the heck. Labs that splurged on cryogenic gear now watch their dreams go. Some scientists try to wiggle out with technicalities. Others, more honest, publish their oops my bad papers. In 1971, Rousseau doubles down in spectral identity, comparing polywater to human sweat and listing 23 trace elements: sodium, chloride, potassium, organic phosphates, protein bits, even amino acids, hiding in Soviet samples. Talk about a sweaty situation. The so-called dense phase? Just a super salty solution pretending to be a new liquid. End of the fairy tale. And the final word, fittingly, goes to Boris Derjaguin himself. Talk about a plot twist. In August 1973, Nature magazine drops a bombshell with a note by Derjaguin and Churayev. Boris Derjaguin says, "Oops, turns out those weird properties were just impurities. Guess we should have cleaned our glassware better." Not exactly a dramatic apology, but enough to put the final nail in Polywater's coffin. Rip Polywater. In just 12 years, the greatest discovery of the century ended up in the scientific blooper reel, right next to Blondlot's N-rays. And let's not forget Schiaparelli's Martian canals and, of course, the infamous cold fusion. Science, am I right? And the final word, funnily enough, goes to Boris Derjaguin himself. In August 1973, Nature publishes a quick note by Derjaguin and Churaev, basically saying, "Oops, those weird properties? Yeah, blame it on dirty glassware. Who knew cleaning was so important?" Not exactly a dramatic apology, but enough to nail Polywater's coffin shut. In just 12 years, the greatest discovery of the century ended up in the Hall of Fame of Scientific Goofs, right next to Blondlot's N-rays, Schiaparelli's Martian canals, and later cold fusion. Ouch. On the surface, the whole Polywater mess seems like a simple issue of dirty capillaries, but it actually reveals a whole circus of human quirks. First up, confirmation bias. When a discovery promises fame, funding, and bragging rights, everyone cheers for the good data and sweeps the bad stuff under the rug. It's like only celebrating the touchdowns and ignoring the fumbles. Next, the power of a good story. A sci-fi sounding phrase like water that turns to indestructible gel grabs headlines, and suddenly everyone from peer reviewers to grant agencies is on board. It's like the media's version of clickbait. Then there's the value of negative results. No journal wants to publish, "We couldn't replicate this," but science moves forward because those red lights keep us from driving off cliffs. It's like the scientific version of "Don't try this at home." From a distance, Polywater is a love letter to replicability. If you can't reproduce it, it slowly loses its claim to reality. It's like a magic trick that stops being impressive once you know how it's done. It's also a shout-out to protocol transparency. Fedyakin's notes were vague, and Derjaguin's were detailed, but lacked raw data. It's like trying to bake a cake with a recipe that says, add some stuff and bake until done. And it's a reminder to stay humble with theories. Water is the most studied yet least understood material, but thermodynamic rules still apply. It's like trying to break the laws of physics with a rubber band. Above all, it's proof of the scientific method's resilience. For 12 years, Polywater fooled Nobel laureates, military committees, and headline writers. But a few careful measurements and some elbow grease brought the truth back. It's like science's way of saying, gotcha. Still, calling the whole saga a waste of time would be unfair. The Polywater chase led to more sensitive spectrometers, better purification protocols, and hundreds of papers that deepened our understanding of liquid-solid behavior on the nanoscale. It's like finding out your wild goose chase actually led you to a treasure map. The disappointment doesn't erase progress, it sparks it. As Einstein said about the ether discovered and then rejected, error sleeps, but knowledge stays awake. So let's keep those eyes open, folks. On the surface, it looks like a simple issue of keeping things clean, capillary cleanliness to be exact, but it actually reveals a whole soap opera of human dynamics. First up, confirmation bias. When a discovery promises fame, funding, and the chance to make your country look cool, positive data gets a standing ovation while negatives are brushed off as oopsies. Then there's the media hype. A sci-fi sounding phrase like water that turns to indestructible gel makes front page news, and suddenly everyone, from peer reviewers to grant agencies, is on board. Even ambitious grad students can't resist. Next, the sad fate of negative results. No journal wants to publish "we couldn't replicate it," but science moves forward because these red flags keep us from going down dead-end roads. From a distance, Polywater is a love letter to replicability. If you can't reproduce it, it slowly loses its claim to reality. It's also a shout-out to protocol transparency. Fedyakin's description was vague, and Derjaguin's, though detailed, didn't include raw data, perfect for wild guesses. And let's not forget theoretical humility. Water is the most studied, yet least understood material, but thermodynamic rules still apply, demanding a ton of energy to break. Above all, it's proof of the scientific method's resilience. For 12 years, Polywater fooled Nobel laureates, military committees, and headline writers. But a few careful measurements and some elbow grease brought the truth back, reminding us that authority isn't a given. It's earned daily at the lab bench. Still, calling the whole saga a waste of time would be a bit harsh. The Polywater chase led to more sensitive spectrometers, better purification methods, and hundreds of papers that deepened our understanding of liquid-solid behavior on the nanoscale. Disappointment doesn't erase progress, it fuels it. As Einstein said about the ether that was discovered and then rejected, error sleeps, but knowledge stays awake. Looking at polywater from a distance, it's like science's way of saying, if you can't do it again, it probably wasn't real in the first place. It's a shout-out to being clear about what you're doing. Fedyakin's notes were like a treasure map with half the pieces missing, and Derjaguin's were detailed but didn't show the whole picture. Perfect for wild guesses. It's a reminder to stay humble. Water is the most studied thing ever, but we still don't get it. It's like the universe's way of keeping us on our toes, but thermodynamics doesn't care about our feelings. Breaking water's bonds takes a ton of energy, and most importantly, it's proof that the scientific method is tough as nails. For 12 years, Polywater had Nobel Prize winners, military bigwigs, and journalists all fooled, but a few careful measurements and some elbow grease brought the truth back, reminding us that being an expert isn't a free pass. It's something you earn every day in the lab. But calling the whole Polywater saga a waste of time? That's just not fair. Chasing polywater led to better spectrometers, improved purification methods, and hundreds of papers that helped us understand how liquids and solids behave on a tiny scale. Disappointment doesn't erase progress, it fuels it. As Einstein said about the ether, which was discovered and then tossed out, error takes a nap, but knowledge pulls an all-nighter. Calling this whole polywater thing a waste of time? That's like saying pizza is just bread and cheese. The polywater chase gave us super-sensitive spectrometers, extreme purification protocols that would make a neat freak proud, and a mountain of papers that made us way smarter about how liquids and solids behave on the nanoscale. Nerdy, but cool, right? Sure, it was a letdown, but hey, progress is all about those oops moments. Remember what Einstein said about the ether? Yeah, even the big guys had their whoops moments. Mistakes take naps, but knowledge pulls all-nighters.